Hello class. In this session we're going to be looking at the measuring of the foundations for the toilet block. And as for the previous examples, what you need to have in front of you is your drawing, your worked example, as well as your standard system for measuring building work, so that you can check as we go along. Right. As we did in the previous example, we are stating our cutoff point that was part of our planning. Now, just to remind you over here, and I haven't put a detail of it on this slide, but you can go and look at it on the section of detail 1. The DPC on the one side is lower than on the other side. So if I can just remind you again, the DPC comes through the internal wall, it goes diagonally down over the cavity, and it goes out the other side. So what are we using as our cutoff point? We have decided that we are using the top of the DPC, in other words, at that level over there. So when we go onto our measure, we must just be cognizant of what are we going to do with that level difference that we have over there. Right. The second bit of our planning that comes out of studying our drawings is our measuring list. Now, you can compare this measuring list to the previous measuring list, and you will see that it is very much the same, except that now we have soil poisoning over here that we didn't have in the previous example. Now, the previous example was a screen wall that is out in the open and exposed to the elements. In this case, we are dealing with a closed floor. So we need to protect our building, and therefore we will have the soil poisoning in the trenches. And later on, when we measure the floor construction, you will see we will also have soil poisoning under the solid floor. But for all the other items that are over here, they are familiar to you. So as I said in the previous example as well, I know that for novice measurers, you actually study these measuring lists off by heart. But you must remember that this is an interactive document. So the whole idea is that you keep your measuring list handy while you are going through your measures. And then when you have measured the first item, which is site clearance, you come back and you tick it. And when you've measured the excavation for the trenches, you come back and you tick it. So in other words, this keeps your train of thought going, and it helps you with your planning so that you don't forget to measure some of the items. Okay, so let's go on to our site clearance measure. Again, in this example, I haven't given you any information to measure the taking out of trees or tree stumps. We will still do examples that have that in. So for now, you can just skip those items, but we are still going to look at the general site clearance. Okay, so you will see here on this slide that I have the superstructure plan in front of us. So that is because I want to illustrate to you that the 1.5 meters that we are adding around the footprint of the building, we are taking from the superstructure dimensions. In other words, from there, we are taking the 1.5 meters out. From there, 1.5 meters out, and so on. We are not going to use the adjusted measures for the foundations that we would do in our collections. We are using the superstructure measures. So if we can just look at the description itself over here, you can also compare this to the previous example and you'll see the description is exactly the same. And then just to remind you again that the 200 millimeter girth that appears here in the description comes from the rule book. It is not a dimension, it's an application of the rule. So it must be stated in the description. Okay, so the 1.5 that I have illustrated to you now on the footprint, so we are adding 1.5 on either side of the overall dimension. So the 4720 over there is then that dimension, that the overall dimension in the horizontal direction, and the 4.41 is the overall dimension in the vertical direction. And in both cases, I add 1.5 past the footprint, and I simply have a bigger square which is around my building. So I derive these dimensions that I want to use in my measure, and I actually use them over here. This is one instance, and if you go to the comments on the feedback on the test, you will also see that I said that these side casts are crucial. If you don't show me how you derive a dimension that you are using to measure, I cannot follow you. So I can't read the 7.72 from the drawing anyway, so I've got to do the side cast before I can actually use it as a dimension. Okay, then we move on to the excavation for the trenches. And I've put on here a clip from the section, because what I want to illustrate to you over here is that the top of the concrete is at the same level for all these strip footings. But the footings that I am circling now are all 200 millimeters thick. And the footing for detail 4, the internal walls over there, is 150 millimeters thick. Here I have it over here. So I am now wanting to look at what is the depth that I want to excavate. So I can come to my section and I can see, okay, there is my natural ground level. I want to excavate to the bottom of my concrete. So I see there is the 350 given over there, and I take the thickness of the concrete to get to my overall depth that I want to excavate. So again, I cannot read that dimension directly from the drawing, so I need to do a side cast. So I'm using the 350 plus the 200 millimeters thick for the concrete, which are the footings circled in red, and I get to the 550. And then my next step over there is again 350. As I said just now, the top of the footings are aligned. So the 350 is the same for all cases. But then I add the 150, which is the smaller strip footing as I indicated just now. And I have the 500 that I want to use there. Now in both cases here, it is not rocket science to see that we are definitely not exceeding 2 meters deep. So if I can just emphasize again, any excavation item must have 4 facts. You can see that I have put them in bold. So just to remind you, you must state what you're excavating in. You must state how deep the excavation is, from which level it is, and what are you excavating for. Okay? The order in which you are writing those down is not overly important, just as long as you write them all there. You can, for instance, say excavating earth for trenches not exceeding 2 meters deep below natural ground level. It is not to say that the word trenches or whatever the item is that you're excavating for must be at the end of the sentence. Okay. So let's just look at the actual dimensions. So now you must start looking back to your collection. You can see from the reference numbers that I have over here on the example, these are the reference numbers that we used in the collections. So now we can cross-reference so that we can keep track of where we are coming from. So if you look through the collections, you will see that the Roman 3 comes from the length of the concrete for detail 1. The Roman 4 comes for the length of the detail 2's concrete. The Roman 9 comes for detail 4's concrete. And the last one, Roman 12, comes for detail 4's concrete. So the lengths then we know come from the collections. Then you can go and look at your sections again and the red circled footings over here are all the same size. So they're all 630 millimeters wide. So you can see I'm using them there in detail 1, detail 2, as well as detail 3. And similarly, I am using the depth of the 550 for all 3 of those, and the 550 then comes from our side cast over there. And then the last footing that comes from the detail 4, again, the length is from the collections. The width of 520 we see from detail over there, and 150, the 350 plus 150 comes from the side cast over there. So I'm using the 500 millimeters deep over here. I just need to stress here again that the fact that the strip footings sizes are different does not mean that it's a different item. Both of these are still excavating for trenches. And the same will happen when we are measuring the concrete. Both of them are mass concrete in strip footings. So we measure them together as it is done in this example over here. So we do the squaring of the example. And now for the next item, which would be then the backfilling and the hard and the soft rock. Again, as for the previous example, I am sticking to my methodology over here as I'm saying, and I am doing the and I'm combining 4 measurable items with 1 set of dimensions. And as my first note is saying over here, I can only combine these descriptions this way if it is true that the 8.86 cubic meters really fits. Is it true that I want to use it for the soft rock, that I want to use it for the hard rock, and that I want to use it for the backfilling? Okay, so just a reminder there on the methodology then. What we're doing over here is we are filling the same volume as what we have excavated, and then when we measure the concrete and when we measure the brickwork in the foundations, we will correct the volume for the filling that we are over measuring in this method. So here where we have many walls intersecting with each other, and each one of them in the collections has been adjusted according to the width of their foundation walls and the adjustment for their concrete. So we don't have to worry about the little anomalies on the ends and the connections, because we're going to use the correct lengths from our collections to do the correct measures when we do the foundation walls. Okay, then just another note over here. The percentages that I am using in this example, the 10% for the soft rock and the 5% for the hard rock over here, these aren't particularly stated on the drawings, but I have stated here in a note that these are actually design requirements. They come from the geotechnical reports. They are interpreted by the engineer and passed on to the quantity surveyor for measuring. So if it's not on a drawing in a test situation, I will definitely give it to you on the paper itself. But I will not leave it up to your own discretion in a test situation, because otherwise I have too many variations due to the number of students in the class. Okay, so for now you can just go with the assumption of the 10% and the 5%. And then just to remind you that you can see here from the squaring that you take the squared total and you apply the percentage once. So it's not necessary then to go and do a calculation for this on the 4 individual items that we have measured to make up the 8.86. Right, then the next item there, the keeping excavations free from water. I'm just confirming again, this is a measurable item according to the standard system. Therefore, you must measure this item. It cannot actually be measured, therefore its unit of measurement is item, and you do state that. So in a test situation, in terms of the marks allocated, you will have a mark for stating that you know it is item, and you will have a mark for the description. Okay, then our next item over here to be measured is the risk of collapse. Now, again, you see a dimension here in the description column. Again, that is a interpretation of the measurement rules, and that is not a dimension itself. So it gets stated in the description as you see in front of you. And here I also want to emphasize that look at the description. It says, I beg your pardon,